Hello everyone, welcome back to Jeff Geo Academy YouTube channel. So in the previous lecture we have already discussed about the elastic behavior of material. So and the elastic behavior of material I have already give a lecture. In my previous lecture I have discussed all those things about the elastic behavior. So today we are going to discuss plastic behavior of material and elastic elastic behavior of material. Okay, so let's start with the plastic behavior of material. So here I have written few things. So note down these things. First thing is beyond a certain value of stress called proportionality limit, Hooke's law no longer holds. Means beyond a certain limit, Hooke's law no longer will be valid. Although the material is still elastic, the stress-strain relation no longer linear. Means beyond a certain limit, stress-strain relation will not be linear. In the previous lecture, we have learned this. This is a linear curve. If this is stress and this is strain, then the resultant curve is linear. Means the stress is increasing and strain is also increasing. But beyond a certain limit called proportionality limit is the key term. Beyond this limit, the stress-strain relation will no longer be linear. Okay. Now, if the solid is deformed beyond a certain point known as elastic limit, it will not recover its original shape. Okay. So, on removal of the applied force, the material will not recover its original shape. And on removal of stress, and here the deformation is called plastic deformation. So when the material on the removal of applied force will no longer be able to return to its original shape, then it is called plastic deformation of the material. Okay. If the applied stress is removed in the plastic range, the strain does not return to, the strain value will not be returned to zero here. In this case, when the stress is removed, the strain value return to zero. But in this case, in case of plastic material, the strain will not be zero. Okay, and permanent strain will be produced. Here, the permanent strain will be produced. So take a screenshot and note down these important points. Now, look at this illustration. This is along y-axis. This is stress. Along x-axis. This is strain. Epsilon refers to strain, and sigma refers to stress. Okay. Now, look here. This is the linear range of elastic material. This from here to here. This is the elastic range. Okay, sorry, this is linear range from here to here. Since it is a linear line, it is the elastic range. Linear range. So within this limit, Hooke's law is valid. Hooke's law, it obeys Hooke's law, and this point we call proportionality limit. Beyond this point, Hooke's law is no longer valid. This is called proportionality limit. I am writing here proportionality limit. Okay. So here to here, this is a linear range, and this point is called proportionality limit, and up to this point, from here to here, up to this point, Hooke's law is valid, and beyond this point, Hooke's law is no longer valid. Now, here I have drawn a vertical line, and from this y-axis to this range. This is the range, and this is called elastic range. Means up to this point, the material is in elastic. So elastic behavior. Now, elastic behavior means the body will return to the same. The body will return to the same position after the removal of applied force or applied pressure. Okay. Now, Okay, now from this up to this point the material will behave like elastic material, and beyond this point it show plastic deformation, means the material will no longer be able to return to its original shape, and and a certain limit will reach where failure occur. Here this is the point of failure. Okay, so or break. Here the body will or the material will break. Okay, at this point. Now all those things I have discussed is written here. In some rock, failure can occur abruptly within the elastic range. Means we are reading geology, not physics, right? So we will talk about the rocks only. So in some rocks, failure can occur within the elastic range. Within this range, most rock or some rock will break down, and this is called brittle behavior. I have written in bold letter in red color so that you can easily understand. So in some rock the break will take place within this elastic range, and this is called plastic behavior, brittle behavior of material, brittle behavior of rock. Now an elastic material deforms immediately upon the application of stress, and maintains a constant strain until the stress is removed, upon which the strain returns to its original state. Okay, so an elastic material will deform immediately upon the application of stress, and we are talking about brittle deformation, and maintains a constant strain. Here the strain, since the strain is constant here, we are talking about plastic deformation. Since at this point the strain is constant and the stress is decreasing, so here which is written and maintains a constant strain until the stress is removed, upon which the strain returns to its original state. Okay, got it? Now take a screenshot. Now we are moving to an elastic material. Now let's switch to an elastic material. So in some material the strain does not reach a stable value immediately after the application of stress. Means after the application of stress the material does not reach a stable value. The strain does not reach a stable value after the application of stress. Means immediately after the application of stress, the strain will not reach a stable value, but rises gradually. Means it rises gradually a stable value. Slowly it rises to a stable value. This type of strain response is characteristics of an elastic material. Okay, this is an elastic material. When the when the strain does not reach a stable value after the application of stress immediately, then this is a characteristics of an elastic material. After removing of the stress, the time dependent strain return reversibly to the original level. Okay, so after the removal of the stress, the time dependent strain return reversibly to the original position, original level. Okay, so in plastic deformation, the strain keeps increasing as long as the stress is applied. So in case of plastic deformation, the strain keeps increasing. It is increasing and increasing as long as the stress is applied. As long as the stress is applied, the strain will increase and increase. When the stress is removed, the strain does not return to original level. I have mentioned already. I have already mentioned this in this lecture, that when the stress is removed, it will not recover its original position, and this is the characteristics of plastic deformation. Okay, this is plastic deformation. Okay, so this is all about elastic and inelastic and plastic material. Now let's discuss this in a graphical illustration so that the concept will be very clear. Now here I have draw a graph. Here this is a y-axis strain and this is x-axis time. So this is a zero level from here to here. This is zero level, means no stress is applied at this point. Now this is the applied stress, and on the left corner this is the stress on, and in the right corner this is the stress off. Now look here, this is the elastic behavior of material from here to here. This is the elastic behavior. Basically I have differentiate between elastic and permanent deformation of material. So this is elastic material from here to here. Sorry. And from here, when stress is on, this is the inelastic type of behavior. Graph will slowly gradually down, and this is gradually up, and this is gradually down. Now this is the permanent deformation. Here stress is on and here stress is off, and when the stress is up it goes like this, and here there will be permanent deformation will occur here. Okay. Now note down one important point here. Our knowledge of the structure and the nature of the Earth's interior has been derived in the large part from studies of seismic waves released by earthquake. So the interior structure of Earth, the idea about the internal structure of Earth is mainly so our idea about the interior of Earth, its structure and its nature is mainly derived due to the earthquake, because earthquake release seismic wave and it gives lots of information about the Earth's interior. So here I'm going to give a few little idea about the earthquake, how earthquake occurs. So here I have written an earthquake occurs when in the crust or upper mantle. So earthquake always happen in the crust or upper mantle. Why? Because of the tectonic stress exceed the local strength of the rock and the failure occurs. So when the two tectonic plate suppose this is two tectonic plate, and it is like this, so it is exceeding stress is accumulating there. So when the stress exceed a limit, when the stress, this is stress, so it is moving like this and it is moving like this. So here in this at this point the stress is accumulating due to friction is also there. So due to this stress, due to this friction, the rock will failure. When the rock failure, and when the rock will failure at some point, the earthquake will occur. It is like this. Okay. So due to this stress is accumulating, use a very tremendous stress is accumulating there. So the stress is accumulating when this stress exceeded critical value, the rock will failure will occur, and away from the region of failure, seismic waves spread out from earthquake by elastic deformation of rock. So away the point of deformation there will be elastic, away the point of failure there will be elastic deformation of rock through which they travel. Okay, and their propagation depends on elastic property. How they propagate, depends on elastic property that are described by the relationship between stress and strain. Okay, let me describe this a little bit more. Suppose this is a tectonic plate and this is also a tectonic plate. Okay, so suppose here earthquake happened and this is the interior of earth and all the materials are like this, and suppose this is our surface. So away this point, here it will travel like this. It will travel all the direction, and this rock, and here there will be a elastic deformation. Only elastic deformation will be there. But when it reaches to the surface, this is the surface. When it reaches to the surface, it causes permanent deformation. Okay, brittle deformation will occur there. Fault will be occur there. So here there will be permanent deformation. So I am not going into detail of the how seismic wave travel, like P wave, S wave, L wave, and B wave. Okay. So these concepts are taught by Sangeeta ma'am, which she has already uploaded her lecture. So if you have not watched her lecture, go and please watch the lecture. Very beautifully she has explained. And if you don't understand, comment in her video, so he can explain you beautifully. Okay, so this is the end of the lecture. In the next lecture we are going to discuss okay, we will discuss it later. What I am going to discuss, I don't know, I will decide today. Okay, so if you have not joined our Telegram channel, join our Telegram channel. This is the end of the lecture. I have given so many questions there. You can do that quiz and for your concept clearance. And you have not subscribe our channel, subscribe. And okay, thank you. And other faculty are also going to join in 2 to 3 days. So stay tuned with the channel. Now, thank you for your patience.